Hello, Mr. Allman here, and this is your Allmancast on making a graph in Plotly. The purpose of this video is to be able to show you some of the basic steps that go into deciding and then actually creating a high-quality graph that's suitable for an IB lab report. For this, I want to go back to the same research question that I utilized in previous tutorials. This research question is the effect of temperature on the rate of respiration measured in the decrease in percent oxygen concentration in Armadillidium vulgare. In other words, I'm looking to see how it is that a decrease in oxygen can be used to be able to show the rate of respiration at various temperatures. Now, in order to be able to choose what type of graph it is that I actually want to use, I have a very nice tool that you can use that I've linked in the investigation handbook. So if I go to the section on graphing, there is a visual guide called the Graph Choice Chart. And when you open up that link, you're going to find this image. And if you start on the left side of the screen, it's going to give you a series of questions. And each of these four colors is going to be one of the four basic types of data that you might have collected for an investigation for your lab reports. Read through each of those questions and choose the one that's going to be the most appropriate based on the kind of data that you have. After reading through each of those boxes, I keyed in on either the green or the yellow box here. The yellow box says, does your question ask if two numeric factors are correlated? One group, two variables. So in this case, I did have one group. It was pill bugs, and I had two variables. My variables were percent oxygen and temperature. So I want to know if temperature and the decrease in oxygen are actually related to each other. So if yes, move on to the next question. Does it ask about something that changes through linear time? I'm looking for different rates, and so even though I did measure percent oxygen over time, the actual relationship I'm looking for is not it isn't going to include time, but rather is just going to include oxygen and temperature. Therefore, I would say no. I'd look at the examples and see that it is, particularly if you look at number 3, fairly close to the data that I have, and so it's instructing me to make a scatter plot. So a scatter plot is the type of graph that I'm going to aim to be able to make in this case. When I go over to my data, I had previously used Google Sheets to be able to process my data, giving me things like average changes in percent oxygen, standard deviations, and rates of oxygen. And this is a little bit messy. This isn't something that I could very easily select all of my data from. So what I like to do is to be able to pick out the numbers that I actually need to use in order for me to be able to construct my graph. Going back to my research question, if my research question is about temperature and rate of respiration, I want to go to my data and I want to find those things specifically. So my temperatures are over here on the left. My temperature range was from 15 to 35 degrees. So I simply typed in over here on the right the temperatures from 15 to 35 in increments of 5 degrees. Then I had the change in oxygen over 3 minutes and the rate of change in oxygen per minute. So this is the number that I want. I don't want individual rates for individual trials, but rather I want the average rate at 15 degrees. That's negative 0.04, and so I copy that over into this little chart on the right. I move on down. Notice that I am rounding because Google Sheets does not automatically round for me, but I know that I need to maintain a consistent decimal place, and so I do that rounding manually as I collect all that information. The last thing that I need is the standard deviation, because if I have an average rate, then I need to know what is the standard deviation for that particular rate, and I copy that into a third column. Now I have this nice compact little set of data, and this is what I want to use to be able to construct my graph. Now, back in the investigation handbook, there is a link to an online program called Plotly. Plotly is a very robust, multifaceted suite of programs that is used by business primarily. But their graphing program is particularly helpful, both because it's free and very user-friendly in its ability to be able to make high-quality graphs. So use that link and open up a new page on Plotly. In the top of Plotly, it's going to give you a grid. So this is a simplified spreadsheet. And so this is where the data can go that you want to actually put into your graph. Below is going to be the field in which your graph is going to appear when you begin to construct it. And on the far left are a series of menus. Once I have Plotly open, I can go back to the data that I want to use for my graph. And I'm simply going to copy that over into the spreadsheet. Okay, I'm going to double check to make sure it copied over all of the columns and rows that I had. Now I'm ready to make my graph. Here in Plotly, a graph is called a trace. And so there's going to give you the options for the different types of graphs that you can make. The default, and the one that I want to make, is a simple scatter plot graph. Then I need to select my the data for my x-axis. Now the x-axis, by convention, should be my independent variable. So my independent variable is temperature. Temperature is located in column A. So when I select my data, I have to pick either A, B, or C. Column A is where my temperatures are located. Then for the y-axis conventionally should be the dependent variable data, in this case the rate of change, and so I select column B. So Plotly will then populate using dots those data points for each of those 5 temperatures. At this point I want to go in and start to manipulate my axes titles. I want to make sure that the axis title lists both the type of data as well as the unit that I'm going to be using. Now that I've specified that information on both the y and the x-axis, I want to give this graph a title. Again, the title can sometimes be fairly lengthy because you want it to be specific to the actual relationship that the graph is visualizing. Okay, so now my title here, the change in the rate of respiration of Armadillidium vulgare at temperatures 15 to 35 degrees Celsius. Again, showing specifically what's in the information that y and x-axis in the context of my experiment. Now at this point, I need to go over to the menus on the left. There are things that you can change in terms of the style. So if you want to change any colors, if you want to change font or sizes in order to make sure that everything that's in your graph is legible and clear, you're welcome to do so. The things that I want to show you are the other components that are really necessary for you to be able to add in. It's going to be under the Traces menu. At the very bottom of the Traces menu, in addition to changing some of the different points there, at the very bottom there's an option to be able to add error bars. And error bars are a key part of any graph that you're going to put into a lab report. Error bars are going to be significant in not only making sure that it's clear that you understand the role of measurement uncertainty in your report, but also it may affect your actual analysis of the results. Because the y-axis is going to be where the dependent variable is located, error bars for the y are going to be usually the only thing that is significant to actually add in. Now by default it's going to add a % error bar, and that's not what you want. You want an error bar that's based on the standard deviation that you had calculated as part of your data processing. So I'm going to highlight the data error type, And now I can choose the data that I want to select for the error plus, which would be the error bar that's above the dot. So I want to choose my standard deviation, which was C. And then I want to choose the error minus, will be the same, also C. And so what that error bar now is going to show, it's going to show me one standard deviation above and below my data point. And I will use this in the interpretation of my graph in my results section. What you can see is that in interpreting the error bars, a safe assumption that you can make as a student is to be able to say that if the error bar is not overlapping, as it is between the 15 degrees and at 35 degrees, then there's likely a significant difference in terms of the rate of respiration at those two temperatures. In other cases, like with 15 and 20 degrees, the error bars actually overlap, and that increases the uncertainty of whether or not there is actually a significant difference in the rate between those two temperatures. So, in short, if the error bars show that the data points overlap, your conclusion is going to be less certain and less strong. When the error bars do not overlap, then you can make a stronger conclusion with much more confidence. There's a little more to it in terms of the actual statistics of determining significance, but this is a good shortcut and a good starting point for you. The final thing that you may want to do is to be able to include a trend line. So under the analysis menu, there's a curve fit and a moving average option. I'm going to click curve fit, and I want to add a curve fit option. The trace, again, is the graph that I have produced using this data, and I only have one trace, so I'm going to select that. I can do basic or advanced, but really for my purposes here, I can stick with basic. I can choose the type of function. Linear and quadratic are the most likely that you will use, and most often a linear relationship is going to be what you're looking for in terms of determining a particular trend, because trends in biology certainly are most often going to be linear relationships. I don't need to add any estimates here. I can just go ahead and click run. And again, what it's going to compute here is a line of best fit showing the linear relationship between the rate of respiration and temperature. So what you can see here is that now I have a line that is decreasing, and it's given me on the left my M value. And so that M value is showing what is my slope. And my slope could be a number that I can reference in my results section, showing the actual the decrease in rate depending on that temperature. I can get a little fancier. I can do things like add annotations, and I can move those annotations around as a way to be able to, for example, explain what this line is, or maybe add that slope in. Once this is all done, I want to save that graph and export that graph as an image. So that image, I can then insert that image into my lab report, and now I've got a high quality graph that's ready for me to be able to add an annotation explaining what that graph is and what it shows, and then I'm going to reference this particular graph in my results section, because this will be important in terms of establishing whether or not there was a clear trend in terms of what the data showed me. Thanks for watching. As always, if you have any questions, please let me know.